Welcome and thank you so much for coming today. My name is Mark Tierman. I'm the Chief Strategy Officer of Bostontdainemics. And for us, that means that I'm responsible for our marketing, our partnerships, and our product management. Bostontdainemics is a small robotics company in Boston, Massachusetts, and our headquarters is located in Waltham, which is a suburb of Boston. And in this headquarters, we have research operations, R&D, and we actually started manufacturing our robots right here in the Boston area. Bostontdainemics was founded 30 years ago out of an MIT spin-off, and we have currently about 500 employees here in Boston, and we became part of the Hyundai family in 2021. Bostontdainemics has 3 robots. We have Spot, which is a quadruped robot, which means it has 4 legs, looks a little bit like a dog, and that robot is used for industrial inspection. We have Stretch, which is a flexible warehouse automation tool, and we have Atlas, which is our humanoid robot, a little bit like our Halo robot or our Formula One research robot. I'm going to go into each of these 3 robots in this presentation and give you a little bit more detail on these robots and what they do today. Let me start with Spot. Spot is an autonomous robot for industrial inspections. That means the robot can autonomously go through a factory and collect a lot of data. Let me give you some examples. In this video, you can see how Spot can be used in an industrial environment, and the robot can be programmed to walk this environment and collect a lot of data. So, for example, the robot could read an old-fashioned gauge, upload the data into the cloud, and then we can put machine learning to understand what is actually on this gauge. What makes Spot so powerful is that the robot can traverse different types of terrain. The robot can go upstairs, the robot can go up cobblestones, and the robot can be outside if need be. And so what makes this an interesting solution is that we're bringing the sensor to the asset, and I'll get into the details of this a little bit more in the coming slides. So ultimately, Spot gives you critical insights into your facility at any given time. We've built Spot as a customizable platform, both from a software as well as from a hardware perspective. That means we have different payloads that can be attached to the robot that give it different functionality. And our robot is designed in such a way that these payloads can get access to the robot's internet and to the robot's power. So any payload can be attached and take advantage of what's already there. And on the software side, we've created open and flexible APIs so that developers can come to us and build new and exciting software for this robot. Our hope is that we are creating a flourishing ecosystem of partners, both on the hardware and on the software side. And ultimately, maybe we'll have something like an app store, where hundreds of developers can come, build software for the robot, and these are almost like apps that can be sold in an app store. There's 3 ways to operate this robot. There's a tablet that ships with the robot that almost makes the robot function like a remote-controlled car that you maybe had as a kid. There's a teleoperation function. That means you can log into a web interface and control a fleet of robots that might be thousands of miles away. So, for example, from Korea, you could log into an interface and drive a robot that's located in a manufacturing facility in Germany. And last but not least, and maybe most excitingly, you can teach the robot to be completely autonomous in your facility. The way that we achieve this is that the robot creates a point cloud, meaning the robot uses its stereo cameras that function a little bit like our eyes in humans to create a point cloud of its environment. And with this point cloud, the robot can localize himself in the environment and know exactly where he is at any given time and find its way. This also means that if you've programmed the robot to autonomously wander through your facility, and all of a sudden there's a forklift truck in the way that wasn't there before when you were programming the robot will autonomously and automatically find a different route to its destination. Even in the last 24 months, we have seen amazing advances in this technology. And we think that in the coming years, our robots will become much smarter and much more autonomous. Today, our robots already work at a level 4 autonomy if you compare it to autonomous car. And we think that will only increase in the coming months. What we're adding now is semantic understanding of the world. So not only will the robot understand where he is in the world, but the robot will also understand what he's looking at. But back to our current use case. We call this dynamic sensing. Dynamic sensing means the robot can walk through your facility and take in a lot of different data. So for example, the robot can listen with an acoustic sensor to a piece of machinery. The robot can look with an infrared camera at a pump and will upload all that information into the cloud, where machine learning can then determine, hey, wait a minute, that piece of machinery sounds different than it sounded yesterday, or this pump runs hotter than it should be. Maybe we should be looking at this and see if this pump will break tomorrow. So basically, this robot allows you to do predictive maintenance on your assets in a way that was never possible before. So why is this so interesting with the robot? Well, because it's this repeatable and standardized data capture that really allows your facilities to become part of the Industry 4.0 revolution. So it starts with gauge reading. The robot can walk through a facility, read an old-fashioned gauge, upload that information, and then machine learning will understand what the reading of the gauge actually is. But where this really gets exciting is if we add sensors to the robot that make the robot see things that a human cannot see. So for example, a thermal imaging camera that can see infrared, or a radiation sensor that can see radiation in a nuclear environment. So adding things to the robot that a human cannot perceive makes this all the more powerful. We've seen a couple of our customers go really deep in some of these use cases. For example, remote inspection, thermal inspection, leak detection with an acoustic sensor to maybe prevent unplanned emissions, or gas detection in a dangerous environment, or noise anomaly detection. So you can envision a host of different preventive maintenance type that could be possible with this robot. And we're really just at the beginning of this journey. Thermal inspection is where we started, and in this video, you see a car manufacturer that is using the robot in autonomous rounds and readings, where the robot is inspecting power cabinets of industrial KUKA robots. These power cabinets contain filters that sometimes break. And when those filters break, the entire production line comes to a halt. And as you know, in continuous process manufacturing, the worst thing that can happen is if the manufacturing line comes to a standstill. So what we're using the robot for here is to do preventive maintenance to stop exactly that. So you might ask, but Mark, why not use an intern that walks around with a thermal imaging camera and takes pictures by hand? And yes, that is a good question. You can do that, but what makes a robot so powerful is the repeatable and standardized data capture. The intern might forget to take a picture. The intern might take the picture from a different angle every day. The robot takes the same picture from the same angle at any given time, every time, at the same time during the day. So this repeatable and standardized data capture makes it so much easier for machine learning to understand what's in the picture, because you don't need to use your computing power to understand, hey, what is actually in this picture and what has changed? No, you can focus on using your machine learning computing power to only detect changes. And that's what makes the robot so powerful. Now you say, okay, I'm not going to use a human then. I'm just going to put fixed IoT sensors throughout my entire facility. That will also give me this repeatable and standardized data capture. That is true. However, we've talked to our clients and we found out that for your most prized assets that are a very important part of your continuous manufacturing, you do want to put fixed IoT sensors because they're so critical to your infrastructure. Fixed IoT sensors cost between $5,000 and $6,000 for each asset, but we have clients that have hundreds of assets. So what we've noticed is that Spot provides the best ROI when you're trying to inspect over 300 assets. So our robots bring the sensor to the asset, and that means more inspections, means more data, means better decisions. So before we go to our next robot, I wanted to show you a couple of futuristic use cases. Now you might say, well, weren't these futuristic enough? You've been talking about walking robots, that's true, but these are even a little bit further out. For example, the Hamburg Port Authority, which is in charge of one of Europe's largest ports, is using Spot to create a digital twin of a 40-year-old bridge that is showing signs of decay in the concrete. So you see in this video how the robot has created a digital twin with both a laser scanner and 3D cameras to create something that looks exactly like the inside of the bridge. And as a next step, we will make this interface available either in a Microsoft HoloLens or in a VR interface so that you can basically teleport into this bridge and see the cracks that might be appearing. HoloLens in general is an interesting use case for us. In this next video, I'm showing you how Microsoft HoloLens or any other AR, VR capability might become the next future interface to these robots. In this video, you see Brian Dallin, one of our engineers, who created a digital twin of the robot in the form of a hologram. And Brian can now manipulate the hologram, and the hologram in turn will manipulate the robot in the real world. This is especially useful as you're trying to do very difficult dexterous things, because controlling the robot with a web interface or the tablet is very good in most use cases, but when you're trying to do very dexterous, difficult things, this holographic interface is sort of the next generation. And you can envision 10 years in the future how this would actually allow you to teleport into a facility, maybe into a humanoid robot, where you could, in essence, become the humanoid and do operations in a very dangerous environment. Maybe it's a mine, maybe it's a nuclear power plant, maybe it's an offshore oil rig that's 100 miles offshore. The last thing I want to show you guys is we just won the prestigious ARIA manipulation challenge. This is a challenge that's being put up by the 4 largest chemical companies in Germany and all their counterparts. And in this challenge, we were supposed to take a sample. So what you see in this video is the robot walking over to a sample station, grabbing a bottle, unscrewing the top of the bottle, then walking over, taking a sample, putting the bottle back and screwing the top back on. All of this is done autonomous without any human interaction. So you can certainly see that this is the next generation of where we are now combining both manipulation as well as mobility. Our robots have been walking anywhere where humans can walk for the last 24 months, but now we're adding manipulation to it. So I'm sure your imagination will run wild on, okay, where could this lead if you're combining manipulation and mobility? Now onto our next robot, Atlas. Atlas is our most famous robot. It's our humanoid robot. It is our Halo robot. We're very proud of him, and he is our core research platform that pushes the boundary of what's possible with robots. Many of you have probably seen the Atlas parkour video on YouTube where the robot really shows off most of its capabilities. So I'm not going to repeat that video. Today I wanted to show you something special. I wanted to show you what Atlas sees when he runs this parkour. So in this video, you can see on the top left screen what Atlas, the video that's on YouTube, and on the big screen, you can see what Atlas sees. So just like our other robots, Atlas creates a point cloud in real time of its environment, and that allows him to perceive the environment. So in this parkour, Atlas knows that a parkour is coming, but he makes autonomous decision on how to tackle this parkour. That means if you change something in the parkour, Atlas would still be running the parkour as he does today. What's interesting in this video is you'll see tiny little green footprints. That is Atlas projecting into the future and planning into the future by about a second. So a green footprint means for Atlas, I know that's where I can place my feet and I will master this parkour. So I thought you would get a kick out of this video that really shows not only what we are capable of, but a little bit of a behind the scenes look of how we're able to do it. And in this next video, I wanted to give a tiny preview of where we're heading with Atlas. Just like I showed you with Spot, where we're now combining mobility with manipulation, the same will be true for Atlas. What I'm showing you here is an animation of Atlas doing just that. And this is actually an animation of our internal tool that we use to program the robot. There's a couple of different ways how we program robots, but this tool is one of them. So what you're seeing here in this tool is sort of the next generation of Atlas capabilities that is coming very soon. And then maybe, as we look 10 years out, at some point, Atlas will probably walk into our daily lives. Maybe first in academia, maybe later in the workplace, and ultimately at home. So your grandkids will certainly have Atlas in their lives. And so here's 2 renderings of how that could look, maybe in a manufacturing environment, and ultimately maybe in some sort of last mile delivery scenario. But again, these are far out scenarios. Coming back to Earth a little bit, why is Atlas important for us today? Well, because he gives us specific things that we can use in our other robots. We've made amazing advances, for example, in actuator technology. But Atlas has also given us a library of trajectory and motion planning that we are using in our Stretch robot today. So next I want to talk about the Stretch robot a little bit. Stretch is an automated case handling robot, which means that the robot is designed to take on multiple functionalities in a logistics environment. The robot is designed in such a way that he can walk around autonomously in a logistics environment and pick up cases. The robot can recognize an individual case, pick it up, manipulate it, and place it elsewhere. The robot has about 10.5 feet reach, can pick up about 50 pounds, has an 8-hour battery life, meaning a full shift, and has about the footprint of a pallet. And so in this video, you see how Stretch can manipulate a case by walking into a container, recognizing what's a package, grabbing the package through its vacuum gripper, and placing it on a conveyor belt behind him. So we think that this robot will revolutionize the logistics industry, and we're starting with truck unloading as our first application. But just like our other robots, Stretch will ultimately do much more. At first, you'll see in this illustration that I'm showing here how the early configurations of this deployment will look. And you'll see that, yes, at the beginning, we're using a little bit of physical infrastructure so that humans don't wander into his workspace. But you also see as time progresses, we will add more and more safety infrastructure directly onto the robot or into the infrastructure of the warehouse environment. And certainly by the end of next year, we are already planning to get rid of some of the physical infrastructure. And if I look 5 years out, we think that most of the physical infrastructure will be replaced by software and safety solutions so that this robot can, in fact, roam around your entire warehouse. And that means the robot will be doing a variety of different tasks. Yes, we're starting with truck unloading as our first application, but we think that the robot will be able to depalletize, it will be palletizing, it will be doing order building, and ultimately it will also load containers. So this is really a very flexible robot that we're launching this year, and we're doing our first deployments in early Q1 of 2023. And then we're scaling this robot globally in the year following. So those are our 3 robots. Thank you so much for taking the time to listen to me today. I appreciate your time, and I'm looking forward to us meeting in person if the situation permits. In the meantime, if you have any questions, please reach out to me. I'm easy to find, and I'm looking forward to the interaction.